Okay, hello everybody. So now we are not going to look at questions. Okay, I'm going to teach you a method to solve chemical bonding kind of questions when they discuss about the melting boiling point. Okay, and students are always very confused. Okay, so I tell you the method. Okay, and let's just strictly focus today. Focus on the simple molecular structures. Right. Okay, so this is actually talking about the simple. Right, molecular structures. Okay, hopefully at this point of time you know how to spot that it's a simple molecular structure, and usually it's a non-metal and non-metal, right? Sec 4, you have, sorry, Sec 3, or some schools even Sec 2, or some students in Sec 2 they learn this. Okay, so how do we analyze the melting boiling point, right? We are checking on the, okay, let's try another color. So the melting boiling point, or how do we compare? Okay, let's make it colorful. Okay, now so okay, so first step. Okay, what's the first step? So the first step, remember, you check for hydrogen bonding. Remember, hydrogen bonding is the strongest kind of intermolecular forces of attraction. So if there is hydrogen bonding, I believe it will have the highest melting boiling point. Okay, so let's say there is no hydrogen bonding. We move to step 2. We check the MR. Right? We check the MR, and remember the concept. Hopefully you can remember, important. The larger the MR, the larger the electron cloud, the stronger the ID forces of attraction. Correct? So remember that. I say one more time. The larger the MR, right? The larger the electron cloud, right? More easily polarized. Okay, therefore stronger ID forces of attraction. Okay, so please remember, right? So we check for hydrogen bonding, step 1. Step 2, we check the MR. Okay, so in the event, right, in the event where the MR is about the same. Okay, remember, is about the same. Okay, usually it's not exactly the same, so about the same. For example, MR of 78 versus MR of maybe 80, right? This is around the same. So how do we do? Remember the process. We check if the molecule is polar or non-polar. Remember how to check? Okay, so polar means what? There is the net dipole moment. There is a net dipole moment. For this, non-polar means no net dipole moment. So of course, when it's polar, you know what happens? It has PD forces of attraction, but no net dipole moment means ID forces of attraction, and of course PD forces of attraction, they are stronger. Okay, so please remember this process, right? So we follow step by step. Okay, and then the final variation. Okay, put it here, right? Number 4, right? If both molecules possess ID forces of attraction, Okay, means the MR is about the same, both ID forces of attraction. We decide on the shape. We check the shape. Okay, check shape as in what? Not VSEPR shape, but linear versus branch. Okay, so of course linear means this way, right? Linear. Branch means maybe circular. So can you see that there is more surface area in contact, less surface area in contact? So of course ID here is stronger. Understand? Okay, so very quickly, let me squeeze it over here to illustrate what's the meaning of linear molecule. So for example, organic compound, okay, this is considered a linear molecule. 1, 2, 3, 4, 5, right? And this is a branch kind of molecule. Okay, so the linear molecule, we have a higher melting boiling point. So this entire steps or process over here, right, if you follow it strictly, you can solve every question. Okay, next video or so, I will discuss a real life example, okay, a real exam question. But for now, right, you use this and then you try your tutorial or try the exam question and see whether you can solve it correctly. Okay, see you, goodbye.